Hello everyone and welcome back to Diksha Karnataka YouTube channel, and you are watching KCET 60 out of 60 in physics series, where we are discussing every chapter topic wise. Also we are discussing previous year questions. So currently we are going through the chapter current electricity, the very important chapter for KCET exam. So if you are preparing for KCET exam, this chapter is must, and we have already completed one part of this video. So if you have not watched this video yet, don't worry, the video is still there in our channel and it is absolutely free. You can go back to our channel in the playlist and you can check the video. Today we are going to discuss part 2 of the chapter. Here we are going to discuss power, energy and cells. Everything is electric. So electric power, electric energy and electrical cells, not biology cells. Okay. So if you are thinking why sir is talking about cells that we study in biology, this is electric cells. Okay. So we are going to discuss about that and different combinations of cells. Also, if you have not joined our WhatsApp channel, don't forget to join our WhatsApp channel. The link is given in the description. Okay. So let's start with today's video. With the list of content in part 2, what we are going to discuss, we are going to start with combination of resistance. Now you should know that combination of resistance as a concept is not there in your syllabus, but it is very helpful if you know all the combination of resistance, because it is already you have studied in your class 10th. But as you are a COVID child, or maybe you are slacking at that point of time, most of the students, when I was interacting with students, I realized that they actually not aware of combination of resistance properly. So I will be giving you basic formula, how to remember it and how you can apply it. Okay, and because we are going to discuss about cells combination, that is also very important, combination of resistance, and it is very similar to that of the combination of capacitors. Okay, so if you have studied combination of capacitors, then you should be able to understand combination of resistance as well. Similarly, if you have studied combination of resistors, you will be able to understand combination of capacitors as well as combination of cells. Okay, that's why we are starting with this. Next we are starting with electrical power, energy. Okay, then we will go to cells. This is electrical cells. Okay, other name of the cell is battery, but cells and battery are not same. I will going to tell you briefly about what is the difference between a cell and a battery, and then we are going to discuss about cells in series and cells in parallel. So let's start with combination of resistance. First combination of resistance that we are going to discuss is series combination. So what is series combination? Let's discuss about series combination first. So if suppose there is a resistance, and resistance symbol you already know, resistance is denoted by this kind of symbol, right? So if there is a resistance, say R1, where R1 ends, that is at this point, another resistance starts. Okay, and where this resistance, say R2 ends, okay, here these two starting points are not linked. Okay, and here we can have other resistance as well. Okay, we can have as many resistance as possible, R1, R2, R3, dot. Okay, n number of resistances. Whenever this kind of combination occurs, we are calling it as series combination. When one resistance ends, another resistance starts. Okay, now in case of series resistance, the combination formula is given by this. Okay, so combination formula is given by, let me erase the unnecessary resistances. Okay, suppose we have few resistances, R1, R2, dot, multiple resistances. In that case, the equivalent resistance, this is called equivalent resistance. What is the meaning of equivalent resistance? If you replace all the resistors using a single resistance, okay, so that the current in the circuit remains same. Okay, all other components get the same amount of voltage or potential. If anything else is attached to the system, then that is called equivalent resistance. Equivalent resistance is a resistance which can be replaced, which can replace all the existing resistance in attached to the circuit, but it will not change any other thing associated with the circuit. For example, the current. Okay, it will not change anything. Suppose there is another component attached which is consuming some voltage, that voltage will also not change. Then that is called equivalent resistance basically. Okay, now next combination is parallel combination. As the name suggests, If suppose I have a resistance R1 like this, okay, another resistance R2 like this, and they are parallel. If you see, they are like parallel lines. So each resistance starts from the same point, okay, starting from the same point, each resistance starts from the same point and they end at the same point, okay. If there are multiple resistance, okay, so they are all starting, these are all connected, right. So they are all starting at this point and they are all ending at this point, right. In some books, to understand this easily, they draw it like something like that. Let me draw that, then you will be able to there won't be any confusion, okay. So they draw it like this. So they all start at the same point and they all end at the same point. This is nothing but same as that combination, okay. Now you can add as many resistance as you possible you want, okay. I am not adding more than 3. So suppose we have some resistances connected like this, okay. Then the equivalent resistance formula is given by 1 by Req. Very important, 1 by Req is equal to 1 by R1 plus 1 by R2 plus dot dot dot. Now if you remember this structure of 1 by is very similar to that of capacitance in series. Yes, whatever is parallel combination, that is similar to that of capacitance in series, and whatever in series combination, that is similar to that of capacitance in parallel, okay. In parallel capacitances gets added, but in case of series combination of resistances, they gets added, okay. So parallel and series are synonymous in case of capacitance and resistances, okay. So you have to remember the difference. If you remember the difference, then there will be no confusion, you will be able to answer any questions associated with it, okay. Now suppose we have only 2 resistances in parallel. Suppose we have one resistance, another resistance, 2 resistances in parallel, okay. Say this resistance is capital R1, this is resistance is capital R2. If 2 resistances in parallel, then their equivalent resistance, we do not need to do this way, okay. Here remember that once you calculate the value, you have to take the inverse to calculate the actual Req. But if only 2 resistances are involved, then you don't need to do too much. You can simply calculate the equivalent resistance. I know some of you know the formula, R1 R2 divided by R1 plus R2, because it is very similar to that of capacitance, right. In case of series combination of capacitance, if 2 capacitances are connected like this, then we can directly calculate the capacitance. Similar to that, parallel combination of resistances, we can calculate the resistance like this, okay. Now electrical energy, power, let us now go into the electrical energy and power. Now suppose here we have a power source, okay. I am not naming this yet. Say this is a supply that supplies some voltage, some potential to this resistance, okay. This resistance is consuming some voltage. Suppose this voltage is V, this voltage is V, okay. This is the resistance R, okay, and there is a current in the circuit. Suppose current is I current is flowing, okay. Now what is happening to this current? This is a potential energy, right. So potential energy is getting wasted here, right. So what other form of energy is being created? That you have to understand, that energy cannot be created or destroyed. So we know that from Ohm's law, V is equal to IR. So continuously current is flowing, the charges are moving, then where this energy is going? Okay, some energy is going to the converted into kinetic energy to the electrons. Now kinetic energy electrons, they are started here, they are going here, they are coming back and stopping it. So basically potential energy is decreasing. Potential energy decreasing means what form of energy we are getting from this. Obviously we know that whenever we switch on a light or switch on a fan or switch on an AC or whatever we are, suppose we are charging the mobile, that current is basically converted into corresponding energy. For example, when you switch on a light, it converts into electrical energy, right. Otherwise also you remember that whenever you are charging a mobile phone, after charging a few minutes, you will see that mobile phone is getting hot, right. So there is also some energy is converted into heat energy, right. So always whenever you are charging a device, Okay, the energy is getting converted into other form of energy. Okay, that is why we say this is a source of energy. Now, how much energy is generated when we are simply connecting it to a battery, and the current is I and the resistance is R. There is a formula to remember. The formula is very simple. Energy used, basically why we are writing H, because mostly we say it is converted into heat energy. Okay, it can be any other form of energy, and electric field is used using the symbol capital E. So, we are not using the symbol capital E. I am using this H symbol. Okay, some other books, some where else you might see some other symbols as well, but I am personally like this symbol H. Okay, H is equal to VIT, vitamin. Remember that energy is vitamin. If you eat vitamin, you will get energy. So, vitamin is VIT. Okay, VIT is the vitamin energy. So, whenever you swallow a vitamin pill, you will get energy. So, energy is VIT, vitamin. Okay, if you remember vitamin, you will remember that energy is vitamin. Now, if we can calculate the energy going through a circuit, okay, we can also calculate the power. What is power? If you remember the mechanical definition, that is the first P when you studied energy and power. Okay, energy is ability to do work, right? So, similarly here, all as we have studied that energy is not only one mechanical energy, there are other forms of energy as well, and energy is conserved similarly, but they are all can be linked, right? Because if energy is one form, even though mechanical energy and mechanical power is linked, but similarly we can calculate electrical energy as well as electrical power. So, what is electrical power? Electrical power is nothing but, in case of mechanical energy, it was energy divided by time, right? Energy divided by time, that was the power, that is the capacity to do work in each second. So, now similar to that, if we take this T and divide it to the H, then we can calculate the power to be VI. Okay, Vodafone Idea, VI. Okay, and if we put this value of V into this equation, we will get I square R or V square R. These are all three equations of power. So, power, sometime we will use VI, sometimes we will use I square R based on the requirement or data provided. Sometimes we will calculate V square by R. Okay, all are same, every formula is same, equivalent. Even if you do not want to use these formulas directly, suppose in one case they have given you I and R, they have asked you to find power. So, you can always use this relation, find V and use the only first equation. Okay, this is only for you to save some time. If you remember the equations individually, okay, then it will save some time for you. Okay, otherwise you can always go back to this V is equal to IR equation and P is equal to VR equation. These two equations, if you combine, you can solve any power equation. Okay, any power problem. It is not an issue. Okay, now application. Where do we use this concept? First of all, when we are transmitting power. Okay, when we are transmitting power to some device, say your fan is you are running your fan in your home. Okay, your fan is rotating in your house, and some power station long away, they are supplying some power. Okay, now your fan is consuming, say, a power P. Okay, your fan is consuming a power P, and the power station is supplying a power, say, PC. Okay, then this is the relationship between the power supplied by the power station, and this is the formula for transmitting that power. This is the power consumed by your home, our household devices, fan in this case. RC is the resistance of the path through which current is being delivered into your house. But you don't need to remember everything. Only thing you need to remember is, this is just a equation, only thing you need to remember is PC is basically proportional to 1 by V square. That is important. Okay, PC, that is power supplied by the power station, is inversely proportional to the voltage. Okay, so higher the voltage, if you maintain this voltage at very high value, then the power loss, this is the power loss, this is basically power loss in transmission. Okay, power loss in transmission. This loss can be reduced, if we keep this voltage at very high value. Okay, so why this is important? Because the power, when it is being generated some hundred of thousand kilometers away and it is transferred to your house, okay, in the way it is heating up the wires that is carrying it, right? So we are losing out some energy. So when the power is being transferred from the power station to your home, the cost of transferring the electricity would be very high if the power is being lost on the way itself, right? So the electric bill that you are paying, you are not paying actually for the power that you are consuming. What electricity bill you are paying? You are paying the bill mostly to bring the electricity from the power station to your house. Okay, and eventually all the power will be gone and you will not get enough electricity to light up your house, because electricity is lost when it was being carried out from the station to your home, right? So what is the solution? The solution is that this power loss can be reduced by increasing the voltage. If we can increase the voltage when it is being transferred, okay, from the power station before it reaches to your house, okay, so that phase the voltage is very high. For example, if you go to a village and if you see high tension wires, they mention 2000 volt, 10,000 volt, in some cases 10,000 volt as well. So 10,000 volts means that wires are actually carrying a very high voltage, 10,000 volt voltage. Okay, but when it is reaching to your house, it is not 10,000 volt. If we give 10,000 volt to your devices, they will burn. So they can only operate at 220 volt. So there is an in-between device that reduces that voltage to from 10,000 volts to 220 volts. Okay, there are actually multiple stages through which it is happening. Okay, and that device is called transformer. We will learn about transformer in another chapter, in later chapter, but not now. But you should know that when the power is being transferred from a place to your house, the voltage is very high to reduce the cost of transmission very low. Okay, this is one of the advantage of knowing about power. Next is the power rating of a bulb. This is a very important concept for KCET. Okay, and this dependency, they might ask, okay, what is the power loss if voltage is say 100 volt against 1000 volts. Okay, if you know P is varies inversely with V square, then you can simply solve that kind of problem. Okay, now power rating of a bulb, you may have seen a bulb called 60 watt 220 volts. Okay, this was a very common. Nowadays we don't see the 60 watt bulbs because we are using LED. So you might find a bulb 9 watt 220 volts. Okay, this is very common. Okay, this is normal incandescent bulb. Okay, with the filament. This is an LED bulb. Okay, this is an LED bulb. LED. Okay, the old generation bulb. 60 watt. Okay, so 9 watt 220 volt. This is called a power rating of a bulb. What is the meaning of that? The bulb has a internal resistance. Okay, they are not telling you the resistance, but you can calculate the resistance using this value. Okay, this is V, this value is V, and this value is a P. Okay, this is the power. When you connect this bulb to a 220 volt supply, it will use 9 watt power. That is the meaning of this rating. Okay, now tell me, what is the resistance of this bulb? That is a homework question. Okay, the time will be around whatever time it is. Mention the time in the comment. Okay, when it is uploaded to YouTube, you can see the timing. Okay, and mention the answer for this question. Okay, I am seeing many students are answering questions without mentioning which question it is, which homework question or any question in between when I am asking. So I may ask you, mention the time. Okay, at this point of time, sir, this is the answer for this question. Okay, so what is the resistance for this bulb? Okay, this is say R old, and what is the resistance for this bulb? Say R LED. Okay, so you mention RO is equal to some value, R LED is equal to some value. Mention that in the comment. Okay, now So this formula is very important. You need to remember this formula. Otherwise, you can solve using the old formula as well. But this will this will be very helpful, because in questions they will directly give you the rating and they will ask what is the current, what is the other values, etc. Okay, so we will solve that kind of problem as well. And if you want to find the current for current, it is simply P by V. So we know that P is equal to Vodafone Idea, right? VI. So we can calculate I is equal to P by V. Okay. Now let us look into a problem, very important problem. If voltage across a bulb rated 220 volt, this is a PYQ. Okay, this is a previous year question. One of the year it came. If voltage across a bulb rated 220 volt, 100 watt drops by 2.5% of its rated value, the percentage of the rated value by which the power would decrease is. So you might think, okay, what to do, what is the formula that we are going to use? So they have given you voltage across the rated bulb is 220 volt, 100 watt, drops by 2%. So voltage is dropping. Okay, power, how much power will change? Now in this case, the bulb will have a fixed resistance. Resistance is not dependent on the voltage, right? So whenever a rating is given, you can calculate the resistance. Resistance is constant, but we are not going to calculate the resistance, but we know that P is basically V square by R. P is V square by R. Now R is constant, only thing that we are changing is V, and we want to find the corresponding change, percentage change in P. So there is a very neat trick about that. So first what we will do, we will find dP. Okay, suppose this is y. So imagine this equation is y is equal to x square by a, same as that. Okay, so a is constant and we are trying to find dy. So what will be the value? Okay, same way. So don't think physics calculus is different than that of mathematics. Only thing is the names are different. Okay, some students I know still struggle with differentiation, especially when it comes to physics, but it is nothing different, it's only the symbols are different. Okay, so what is the differential of x square? 2x dx, right? Similarly, it will be 2v dv when you are doing it for v square. Now 1 by r is constant, so it is constant. Now what we will do, this is the trick, this is a very physics specific trick. What we are going to do, we are dividing both side with the value of p. Okay, so on our left hand side we write dp by p. On our right hand side we will not write p, but what we will write? We will write this side. On left hand side we are using p, on right hand side we are using this. Okay, same equation. So v square by r on our right hand side. Now we will cancel whatever is cancelable. So 1 by r is here, this is also 1 by r, so this will cancel, and there was 2v here, 1v will cancel, right? So here on our right hand side we will get 2 dv by v, right? Cool. So if you check, you can check this calculation once more at your own pace in your own notebook and check if I have done anything wrong. So 2v by 2 dv by v. Now dv by v is basically the change in percentage. If you multiply it with 100%, so dp by p per times 100% and 2 times dv by v times 100%. Okay, this is the percentage. But since it is an equation, both side will be will have 100% multiplier, so we do not use the 100% multiplier here because that will eventually cancel out. So if we are using percentage on our right hand side, we will get a percentage of percentage in our left hand side as well. Now for dv by v, okay, so for dv by v, percentage is given 2.5%. So we just need to put that value 2 times 2.5%. Okay. So basically what is this problem is about? This problem is about two things. First of all, you need to know this relation. Okay, so they are asking you that you need to know this relation only. This problem you cannot solve using P is equal to VI relation. Okay, you have to know this relation, and here because the voltage is changing, current will also change. So you cannot use P is equal to VI relation. Only thing that is constant, that is resistance. Okay, for any bulb or any device when it is given to you, only thing that is constant, it is resistance. Okay, its resistance is constant. Okay, because you can change the voltage accordingly, current will adjust, but the resistance of the circuit, any given circuit, is constant. Okay, there are some electronic circuit, obviously in our real life electronic circuits resistances they do vary, but for most common devices that we are using, electrical devices, their resistance is constant. Okay, and in that case when the power rating is given, definitely the resistance is constant. So when the resistance is constant, only thing that is varying is voltage here and power here. Okay, so we just need to do the differentiation. You need to know how we can do the differentiation, how we can calculate the percentage calculation, then we can calculate this part. Okay, so correct answer is option A. So only thing they are asking you to remember this formula and how you are treating this problem. So treatment is one and one is knowing. Okay, both things they are emphasizing on how to remember. Okay, now next. Now let's look into the homework problem from yesterday. Very important, interesting question. A wire of certain material is stretched slowly by 10%. Its new resistance and specific resistance becomes respectively. Now, as we know that specific resistance, I told you specific resistance is the resistivity of the material, that is rho, and rho is constant for a given material. So remains the same is the option. So remains the same. So basically if you read the question, so it is like KBC 50-50. Okay, this question, this option is wrong, this option is wrong. So rho is not changing. Here they have said it will be 1.1 times, so that is not happening. So only thing that you have to be careful that which one is changing. So both remain the same is obviously not correct. So without reading the question, without doing any mathematics, you can simply answer option A. Okay, so for this specific question, this is a yearly question. So you don't need to solve the entire thing, you don't need to do anything, you just need to read the question. Okay, the resistance, the wire is stretched slowly, 10% increase, but they have given you the option such that you don't need to do any mathematics. Now, this was previous year question. So if the similar question comes in your year, where it is very difficult to guess which one is the correct, so you need to know the mathematics as well. So now I am going to do the mathematics, but this is a pro tip for you that whenever you are answering a question, read the question once, especially meaning of the question and the options, whether this is making any sense or not. Okay, during my strategy video I told you read the question properly before answering. This is the reason. Okay, this problem you can solve in less than 10 seconds if you can do the mathematical reasoning. Now it is said that the length is increased by 10%. So we know that length times area is constant, volume is constant, because even if you are increasing the length, its area will decrease. So now new length L2 A2, okay, and new length is increased by 10%. So initially if the length was L, that is L1, okay, the final length will be 10% more. 10% more means 1.1. You remember that. 20% more means 1.2. Okay, 50% more means 1.5. 100% more means double. Okay, 200% more means triple. Okay, so you have to add 1 plus the percentage divided by 100. Okay, that is the percentage law. If you have forgotten that from your lower classes, then this is the recap. Now L2 is basically 10% more, so this is 1.1 L1 A2. So A2 is basically L1 will cancel, A1 divided by 1.1 thing. Okay, now you can use the shortcut method also, that I will show you after this problem. So we know that resistance, new resistance is basically rho L2 by A2, right. So, rho L2 is 1.1 L1 divided by A2 is A1 divided by 1.1. This 1.1 is in denominator of the denominator, so it will go up to the numerator. So, it will become rho times 1.1 whole square L1 divided by A1. So, it will be 1.21 rho L1 by A1. So, it is basically 1.21 times. So, 1.21 times. This is the way of solving it. Okay, one more thing I told you, whenever the length is changing, okay, whatever the changed length is, it is the square of that. Okay, new quantity will be square of that. So, if it is double, then new resistance will be 4 times. If it is tripled, new resistance will be 9 times. So, here it is 1.1 times. So, new resistance will be square of that time, only times value, not the L1. Okay, so it will be this. So, 1.21 R1. This is the shortcut method. If you remember this value, this is ogle. Otherwise, you can calculate this way. This is the longer way, understanding way. This is the shortcut way, cheating way. Okay, so whatever way you like, and this is the most shortcut way if you read the question properly. Okay, so if you have read the question properly, you could have answered this question without any difficulty. Now let's look into the next problem. A copper wire of length 1 meter and uniform cross sectional area 5 times 10 to the power minus 7 meter square carries a current of 1 ampere. Assuming that there are 8 times 10 to the power of 28 free electrons per meter cube in the copper, how long will an electron take to drift from one end of the wire to the other? So, what is the problem? There is a copper wire. Suppose this is a copper wire. Okay, the length of the copper wire is given 1 meter. So, 1 meter is the length of the copper wire. This is the length. Okay, and it is said that the cross sectional area is given by, this is the cross sectional area, right. So, cross sectional area is given by 5 times 10 to the power of minus 7 meter square, carries a current of 1 ampere. So, it is carrying a current 1 ampere. Okay, here this A is cross sectional. So, there may be some confusion. Let me remove the confusion and make the cross sectional area small a. Okay, because current is also ampere. Okay, so let me use this small a. Okay, now assuming that there are 8.8 times 10 to the power 28 free electrons per meter cube in copper, how long will an electron take to drift from one end of the wire to the another? So, one electron, okay, to drift from this end to the other end. Okay, so basically what we have to do, we have to find the drift velocity. If we can calculate the drift velocity, then what is the main thing that we need? We know the length, this is the distance. Okay, this is the distance S. Okay, so S equals to Vt, that formula we will use. So, T equals to S by V. Okay, in this case this will be Vd, right, drift velocity. So, same equation as the electron is like a car, that car you are driving at the drift velocity, how long it will take to cover 1 meter distance, right. Now, how we can calculate drift velocity? We know that current is given by NEA Vd, right. This is the formula that we learned yesterday. So, current is NEA Vd and current is given by 1 ampere. Okay, number of electrons per meter cube, that is N, is given by 8 times 10 to the power of 28. Charge of an electron is 1.6 times 10 to the power of minus 19. Okay, area is given by 5 times 10 to the power of minus 7. Vd we are trying to calculate. Okay. So, now what we have to do, we have to just simplify it. Okay. 5 times 1.6 is 8. So, 8 times 8. Okay. times 10 to the power of 28 minus 19 minus 7, that is minus 26. So 10 square Vd. So Vd will be 1 divided by 6400. So 8 is the 64, 10 square is 100. So 1 by 6400, okay, meter per second. Okay, so this much meter per second is the drift velocity. As you can see, this is a very low value. Okay, and then we can calculate the time as 1 meter divided by Vd. Okay, that is 1 divided by 1 by 6400, right? 1 divided by 1 by 6400. Nice, no? So answer is 6400 seconds. Okay, now let's check the options. What are all the options? The options were 6.4 times 10 to the power of 3. So you can see that we can rewrite this as 6.4 times 10 to the power of 3, right? So we can rewrite this as this second. So you can see that this is a very high value of time. Okay, so 6.4 10 to the power 3 second means it's a very high value. It's not very small value, right? So the drift velocity is very, very low. This is a actual problem where you can understand that drift velocity is very low value. This is also from your one of your previous year questions. Okay, so you need to understand how you can answer such questions if you know where to start and where they have asked you to find. Okay, these are not very difficult questions, but you need to know the strategy to solve this kind of question. Okay, now next is cells. So what is a cell? Cell is basically a building block of source of power or source of energy, okay, electrical energy, and they start with one large side, one small side. Okay, this is how we draw a cell. Okay, this is your tiny double A cell or triple A cell that you are using in your remote or your remote control car, or even the small button cell that is used inside your watch, or there is a cell inside your mobile. Okay, they are all basically basic unit of that is called cells. Okay, cell is one unit, right? Same that is going for your biology, that is the unit of life is called cell. Similarly, unit of electrical power is called cell. When multiple cells combine, okay, to provide you a high enough power or high enough energy required, okay, then that is called a battery. This is a battery, okay, and this is a cell. Okay, cell is the building block or unit, one unit. When multiple cells combine, this is called a battery. Basically, when we are saying this is a battery, give me a battery, actually battery means there are multiple cells involved. Okay, but when you are saying 1.5 volt cell that is used in your remote control car or in your wall clock, that is a cell. Okay, in fact, then the same thing used in your mobile phone, there they have multiple cells combined. Okay, that is why this is called a battery. Okay, so battery and cell is basically where we are saying multiple cells are combined, then it is called a battery. Now cell, even though so far whenever we are drawing only like this, and we are saying the voltage supplied by it is V. Okay, but this is not correct, as cells also have something called an internal resistance, because cells also are made up of some components. Okay, so if you study about electrolysis, in electrolysis is basically a process opposite to that of cell. If you are using a cell, then there are electrolytic cells where you are using chemicals to generate electricity, and in electrolysis you are using electricity to create some coating on metals, right? But if it is opposite to that of that is called electrolytic cell. Okay, and there is some resistance involved inside that liquid. So that resistance is called internal resistance. Electrolytic cell is the one of the oldest and well known cell. There are multiple dry cells. For example, the cell that you are using in your remotes or remote control car or in your wall clock, they are dry cells. Even the dry cell is one of the dry cell is used in your mobile phone. Nowadays, electric vehicles are there. Okay, EVs. Okay, electric vehicles, electric scooters. Okay, you may have seen that in your place. So those are also made up of cells, and then cells are combined and they are made up of, they are calling it battery. Okay, we have 5000 mAh battery. Okay, so mAh is, we can discuss that in a future video, what is the meaning of that. But for now, you should know that cell means there is a cell of power supply and there is an internal resistance R. Okay, and the power that is actually supplied by the cell or the voltage of the cell is called EMF. Okay, electromotive force, not voltage. Oh, even though EMF and voltage are synonymous and sometimes they are interchanged, also they have the same value, same meaning. Okay, so but in case of cell, we are no longer using voltage, we are using EMF, that is electromotive force. Okay, and the entire thing can be replaced by our ideal cell. Okay, entire thing without the internal resistance, we can replace it using simple a voltage V. Okay, that voltage V, this V is not same as the EMF. Okay, this V is not same as EMF, but we can equivalent, like we have learned for resistance. Similarly, we can equivalently replace the cell using a volt supply, and that voltage is given by this formula. V is equal to epsilon minus IR. So when you are connecting this cell into a circuit, say into a resistance R, okay, you are connecting that cell, and in case of cell, this internal resistance is always drawn next to the cell. Okay, you remember that internal resistance is always drawn next to the cell. Okay, and if the current in the circuit is I, okay, then this is the relationship for voltage. So if you want to replace this, using our known voltage source, so in that case, voltage source, if you are replacing it using this, then this is our V. But generally this is an ideal case. Ideal case we are not interested, we are now working on some real cases. So we are using this. This is called cell. Okay, and whenever you are saying, if you are needing two cells, okay, some of your cars may be needing two cells, some of your remote control needing two cells. So they are combination of cells. They are called combination of cells. So combination of cells means when we are needing multiple number of cells. Okay, so combination of cells. Now this V is given by IR. We know that V is given by IR. So IR is equal to epsilon minus IR, or you can calculate the current I using this formula. Okay, so instead of V is equal to I by V by R, I is equal to V by R, in case of cell, you need to accommodate or accompany the internal resistance as well. So basically what you can do, you can think as this resistance, internal resistance is in series with the all external resistances. All combined external resistances, this resistance is in series. Okay, now this is only for single cell. Now we have to understand when we are using multiple cells, okay, that we are calling combinations of cells. Let's look into the combinations in cells. There are two specific combination. One is cells in series. So like resistances, if we can combine one cell, okay, when one is ending, another cell is starting, then this is called combination in series. Okay, in this case, the equivalent EMF is given by this formula. Okay, epsilon 1 plus epsilon 2 plus epsilon 3, and the equivalent resistance of the cell is given by this formula. So what is the meaning of that? If we replace this entire combination using only one single cell, okay, then this internal resistance is Req and this resistance is Req. Okay, then that value of Req, epsilon Eq is epsilon 1 plus epsilon 2 plus epsilon 3. So Suppose you have combined multiple cells, okay, each having internal resistances, say R1, R2, R1, R2, like this. Okay, you have combined multiple resistances. Sometimes some students said, sir, your R looks like V. It is R, okay, V is different. My U and V might be maybe sometimes similar, but R is R, V is V. Okay, so don't get confused. Even if you are not able to understand any symbols that I am writing, you can mention that in the comment below. Okay, now this is the formula for cells in series. Let's look into the formula for current. Current is given by I is equal to epsilon EQ by R plus REQ. As I said, the external resistance can be considered to be series with the internal resistance. Okay. Now, a car has a fresh storage battery of EMF 12 volt and internal resistance 2 into 10 to the power of minus 2 ohm. If the starter motor draws a current 80 amps, then the terminal voltage when the starter is on. So what is the meaning of that? That you have a battery and cell are synonymous. When they are calling battery, that means they have combined everything and they are giving you the final value. So EMF is given, that is epsilon is given 12 volts, okay, and the starter, the internal resistance is given 2 times 10 to the power of minus 2. Now the motor, when the motor is on, it is drawing a current of 80 amps. Okay, so when this motor is on, I is given as 80 amps. What they have asked you? They have asked you to find V. Okay, find V. Now we know that V is basically epsilon minus IR, right? We already learned that formula. So we simply use that value. 12 minus I is 80. R is 2 times 10 to the power of minus 2. Okay, so 12 minus 160 times 10 to the power of minus 2, that is 12 minus 1.6, that is 10.4 volts. Okay, so 10.4 volt is the answer. Simple. Now, next is cells in parallel. Cells in parallel means similar to that cells in series, when we are connecting the cells that we have done in series combination, but now they are all connected in parallel. Parallel combination I already explained, okay, in the combination of resistances. That's why I explained that in the beginning of this class, so that you don't get any confusion what is parallel combination, what is series combination, right? Now this is called parallel combination, and in parallel combination, suppose the EMFs are epsilon 1, epsilon 2, epsilon 3, epsilon 4, okay, and this is R1, R2, and this entire thing can be represented using a single circuit, single cell of only one epsilon equivalent and R equivalent. Then this is little complicated. Cells in parallel is little complicated. This is not very often asked, but sometimes they asked problems based on cells in parallel as well. And the formula that you can remember easily, okay, the formula that you can remember easily and solve easily is this. You remember this formula, okay, there is plus, but generally they don't give you more than 2 cells, or they will give you same cells and same internal resistances, okay, so that it becomes n times of that, right? So I may be solving you one such question in future, but right now just look into this. So epsilon 1 by R1 plus epsilon 2 by R2. So whenever you are saying this divided by entire resistance. Now if you see, these all resistances are connected in parallel, so you can assume these are all the equivalent parallel resistance of this combination, okay, and you can write the equivalent resistance. As I said, they are all in parallel combination, so it will be simply the parallel combination of the resistances, right? So current is given by I is equal to E epsilon q by R plus. This formula is same for no matter what combination you are using, but in this case R eq is changed. So you can also write this epsilon eq divided by R eq. This is another formula that you can remember, is basically, so whenever you are calculating the combination of resistances in parallel, first thing you need to calculate is R eq. This is the first thing that you need to calculate. Then you can use this formula. This is another formula that you can remember easily if you are getting confused. Okay. Now we are at the end of this lecture, so this is time for homework. So I am here with two homeworks as usual. Please pause the video, take the try to solve this homework problem as it is, and mention the answer in the comment below, or you can use the PDF that will be provided at the end of the lecture. Okay, that can also be used by you to answer the homework questions. Now next homework question is this. So pause the video if you want, and take a screenshot and answer the question as given in the homework problem. This is the second homework problem, very interesting problem. I am going to explain with the answer in our next video. So be patient and wait for that. So we are at the end of the lecture. So if you want to know more about all the videos that is available in our channel, you can go and visit this playlist, KCET 2025 Physics 100-day complete preparation strategy, where we are discussing all the topics. This video is also going to be part of this playlist. So here you can find all the videos that is already uploaded and available. So you can check there with all the videos, and in the end of the video there is a PDF available. All the lectures PDFs are also available, and please join our WhatsApp group, where we are sharing all the updated videos. Whenever we are posting a video, it is getting updated in the WhatsApp channel. Here you will get not only physics, but you are getting updates about chemistry as well as NEET biology. If you are interested in NEET biology, that is also going on, and we are soon starting with mathematics as well. So if you like this video, don't forget to subscribe to our channel, and if you are watching this video for the first time, obviously subscribe and share it with your friends. Thank you for watching.